This note is titled Denominators. Polynomials can be set up as rational expressions where there's a polynomial p of x as the numerator and a polynomial q of x as the denominator. So just a reminder that the top of the fraction has a special name. It's called the numerator, while the bottom is called the denominator. We will be performing polynomial operations with these rational expressions. So we previously talked about simplifying, and then we did multiplication and division. Some operations require a common denominator, and we will need to make connections to our prior knowledge of basic fractions to these polynomial fractions. So let's review adding and subtracting with basic fractions. You can see in this first round that both sets of fractions have common denominators. When you have a common denominator, you can actually add or subtract with those fractions. And the rule for that is you keep that common denominator and you only combine those numerators. So 1 plus 4 becomes 5. And then you would reduce your fraction and see if you can make a smaller fraction by dividing by a common factor. Since 5 is prime and 9 cannot be divided by 5, that one is already in simplest form. Same thing for subtraction. You have to have a common denominator, and so you would keep that denominator and then you would subtract with just those numerators. So 9 minus 6 would be 3. Again, simplify fractions, but 3 and 11 are prime. When you have fractions with different denominators, you have to create what we call a common denominator. And there's different ways that this is taught in the younger years. One of the most popular ways to do a common denominator in middle school is what they call the butterfly method. However, we try to avoid using that in the higher mathematics because of the way that our denominators are set up as. They're not just monomial numbers, they're binomials and trinomials and things like that. So we're going to focus on how to create a common denominator without our little cutesy shortcuts. So one of the ways to do that is to simply multiply by the other denominator. If our first fraction has a denominator of 3, then I would multiply by 3 to my other fraction, and then I have to keep my balance. Whatever I multiply to the denominator, I must also multiply to the numerator. I would then take my second fraction's denominator and multiply that to my first fraction, both to the denominator and the numerator, to keep a balance. When that happens, we will end up creating equivalent fractions where they have matching denominators. So my first fraction, its equivalent form is 10 over 15 because 5 times 2 is 10 and then 5 times 3 is 15. My second fraction would become a 9 over 15. And then once I create that common denominator, I would follow the rules from before. I would keep that common denominator and only add those numerators. So 10 plus 9 would become 19. And then I would try to reduce my fraction. And then again, 19 is also prime. Another way to do it is called the least common multiple. Because sometimes when you do, we call this one over here the switch method, where we literally just switch the denominators. Sometimes there is a way to do it without switching, where you don't make such larger numbers and you look for like the least common multiple. So that was taught to you long time ago in the younger years. We say LCM for least common multiple, and you would list all the multiples of those denominators. So 7, 14, 21, 28, 35. And then you would do the same for the 4, 8, 12, 16, 20, and you would keep going until you found that least common multiple. So we can turn each of these denominators into that least common multiple by multiplying it. And sometimes it does end up becoming the switch method, but again, not always the case. So if I want to turn 7 into a 28, then I would times by 4 to both the denominator and numerator. I would do the same with my second fraction and multiply by 7. And then create those equivalent fractions. Again, 4 times 3 is 12. 4 times 7 is 28. 1 times 7 is 7, and then 4 times 7 is 28. And then now that we've created that common denominator, keep that denominator and only focus on the mathematics with those numerators. 12 minus 7 is 5. So we're going to be doing that switch method a lot, but sometimes when we do that switch method, we make bigger and bigger fractions, and we don't always want the biggest because we want everything in simplest form. So we do more of what that LCM is, and it is called creating a common denominator. Before we start doing that, I also want to keep in mind that because our fractions are made up of polynomials, there's going to be x's at the bottom of that fraction that cannot exist because you can't divide by certain numbers. So we are going to be introducing what we call excluded values, and that is the values for all the x's in the denominator that would turn into a 0, because as soon as we divide by a 0, we create an undefined function, and that's going to become something later on in our next portion in a couple of weeks with graphing. So for now, we're just going to start practicing that skill called identifying excluded values. So you're going to factor like we had been practicing before. And so we're going to factor the numerator and then factor the denominator. So let's look at this numerator here. Right now it is not in proper form, so we're going to rewrite it as standard form. And then let's go ahead and take out that GCF. We do have a negative as a leading coefficient. Both of our coefficients are a 1, so our GCF is definitely going to be a -1. And then when I divide by -1, we're going to get x squared minus 1. That is a difference of squares, and so we would do our x plus 1, x minus 1 from there. So our new numerator, just going to rewrite it, would be our GCF, and then our difference of squares. For our denominator, that is a linear factor because our highest exponent is 1. So the only kind of factoring that we can do is a GCF. Well, again, both coefficients are a 1, and so that is already in factored form. So first thing is, let's find our excluded values. That's the new part. Our excluded values come from the denominator, and we're going to set it equal to 0. But you want to do that from all of the factors. Because x minus 1 is already the factor, we're just going to set it equal to 0 and solve for x. So we only have one excluded value here. X cannot equal a positive 1. If you were to plug it back in here for our x, 1 minus 1 would become 0. And as soon as you type in a number divided by 0, you get an undefined value. You can always check that with your calculators if you're not certain, but that again is what we are looking for when we say excluded values. All right, and then from our last notes, let's go ahead and simplify that expression. Since now we have everything in factored form, find those common factors and divide them out. And then your remaining factors will be -1 times x plus 1 in factored form, or you could distribute it and get it to standard form. All right, let's go ahead and try again, looking for some excluded values and then simplifying. So let's take our numerator, x squared plus 5x plus 6. That is a trinomial. Let's go ahead and do our GCF of that, and with that leading coefficient of a 1, which means we can go ahead and jump into our snowflake. Let's take our a times our c, so 1 times 6 is 6, our b on the bottom, and then let's do our ax on the top shelves. We want two numbers that multiply to 6 but add to a 5, and so we're going to do a +2 and a +3. We'll of course have to simplify our fractions, but because our leading coefficient is a 1, we can't get any smaller than that, and so we're just going to write our factored form. Because our GCF is 1, we don't technically have to write it, but for sure, let's go ahead and do our two factors that we created from the snowflake. All right, down on the bottom, I have two different polynomials here. So let's factor one at a time. Again, that one is a trinomial. So let's do our GCF. Leading coefficient is a 1. And then we would do our snowflake. And then A times C with our B on bottom. Our A next to our X's. Two numbers that multiply to 2 that add to 3 would be +1 and +2. Again, you would want to simplify your fractions, but because of that a value being a 1, we cannot get any, we cannot get any more reduced than a 1, and so those are just going to stay as x plus 1 and x plus 2. And then looking at the second portion here with that x plus 3, again, that's a linear factor because your highest exponent is a 1. So the only thing we could do is a GCF. But again, we have a coefficient of 1, so that's going to stay as x plus 3. So our excluded values are going to come from all three factors in the denominator. So we're going to take each one of those, set them equal to 0, and then solve for x. So we have -1, -2, and -3. If we were to substitute those in for these x's, you would end up getting a 0 at the denominator, and we cannot divide by 0 because that creates an undefined value. From there, let's go ahead and simplify our expression and look for common factors. I see an x plus 2 on top and bottom, so let's go ahead and divide those out. And then I also see an x plus 3, numerator and denominator, and let's divide those out. And so we're left with, technically, a little hidden GCF up top. We can't leave it blank, so we do have to put a filler in there. So we have a 1 as our numerator and x plus 1 as our denominator. Okay, for our rational expressions, remember we have our little factoring checklist that we're going to start working on getting programmed in our head. And now we're going to do our second skill, which is creating common denominators. To do that, we're going to factor the denominators and then identify any missing factors so we can do what is called the switch method, where we can create an equivalent expression by introducing the missing factor. Remember to keep a balance between the numerator and denominator. So if we have to multiply by something down below, we're going to do the same thing and multiply up above. So let's go ahead and do our LCD. So let's start to factor, just like we did before, numerator, denominator of the first fraction, and then numerator and denominator of the second fraction. All right, so that 3x, that is a linear, highest exponent of 1. It is a monomial, so we cannot factor that anymore. Let's go ahead and leave it as a 3x. On the bottom, 3x plus 6 is also linear, but there is a GCF with that binomial, 3x and plus 6. So our GCF here is 3, and when we divide by 3, we're left with x plus 2. And then our second fraction, that 2 is a monomial, so it can't be factored further. And then our denominator does have a GCF of a -1, and when we divide by -1, we get x plus 3. Okay, so then we need to create what is called a least common denominator. That is, we have to have matching denominators. So first, look for anything in common. Sometimes you already have a match. So these are definitely not matching. The left fraction in orange has a 3, the right has a -1. The left has an x plus 2, the right has an x plus 3. So there's nothing in common. So we're going to do that switch method. Whatever's in that first fraction, we're going to multiply into our second fraction. And then remember, we have to keep our balance. Okay, and then second fraction, whatever that one has, we're going to multiply into our first fraction. So let's go ahead and times by -1 and an x plus 3. And then keep your balance to the numerator as well. So what you can see down at the bottom is we now have 4 factors. They are, and I'm going to reorder with our monomials in front. So we had a 3 and then a -1, and then we had 2 binomials, x plus 2 and x plus 3. Now I can simplify my monomials to make it a little bit easier, but I don't want to combine my binomials because we want to keep them in that factored form. So let's make this our LCD. For our equivalent fractions, our equivalent expressions, we're going to reduce as much as we can from our balanced fractions. And so up top with that 3x, -1, and x plus 3, I could rewrite that as a -3x with an x plus 3 over my LCD. And then same thing on my second fraction. I can combine my monomials. 2 times 3 would be 6. And I'm going to leave that binomial in factored form. And then my LCD again. Now we will add to this later, but right now I just want us practicing that rewriting. We are going to be adding and subtracting in the next portion. And so being able to rewrite it in that equivalent form, it's going to make it a little bit easier for us to do the adding and the subtracting. All right, let's try again with example 2. We're going to factor everything, numerator and denominator of first fraction, numerator and denominator of second fraction. So we have x minus 4 as a linear, no GCF other than a 1. And then our denominator of the first fraction, that's a trinomial, so we're definitely going to try a snowflake there. Let's look for a GCF first. So our GCF, it looks like, is going to be a 1, with our smallest number being a 2. That's a prime number, so the only factors of that are 1 and 2, and 7 does not work with that 2, so it has to be 1. So when divide by 1, it stays the same, and then we can just jump into our snowflake. 2 times -4 is -8. B at the bottom, your AX on your top shelf, left and right side. So we need 2 numbers that multiply to -8, that add to -7. That's going to be a -8, +1. Of course, we always want to simplify our fractions. So 2x minus 8, we can divide both of those by 2, and we get 1x minus 4. So that's going to be our first fraction there. And then, first factor there. And then our second fraction, 2x plus 1. Because of that 1, you can't get any smaller, so it's already in simplest form. And then factoring our second fraction, x plus 1 is linear. GCF is a 1, so it's not going to factor more. And then our denominator is a trinomial. We do have a 1, so that means our GCF is a 1. And then we can go ahead and jump into our snowflake, a times c, b at the bottom, ax on both sides. 2 numbers that multiply to -12 that add to a -1. That would be a -4, +3. And then because of those 1s, we can't get any simpler. So we're going to say x minus 4 and x plus 3. So that's our factored form. First thing is, let's create an LCD. So looking at our denominators, we actually have something in common, which the last one did not. So I'm going to highlight that here in blue. I have an x minus 4 on the first fraction and an x minus 4 on the second fraction. So that part's already matching. It's already present in both of those polynomial expressions. So all I'm going to do for my switch method is the one that's not there. So my first fraction has 2x plus 1, so I'm going to multiply that in to my second rational. And then everything that's on the left is on the right side, but my right side has an extra factor of an x plus 3. So we're going to multiply that in to our first fraction. Now we're going to want to go ahead and keep those binomials together so we don't actually start doing some weird math. And then looking at our LCD, we have 3 factors in common. We have x minus 4, 2x plus 1, and x plus 3. Now there's no monomials, they're all binomials, so let's go ahead and leave them like that in factor form. And now we're going to write our equivalent expressions. So let's take that first fraction and see if we can combine anything in that numerator. But that x minus 4 and that x plus 3 are binomials, so let's leave them like that for now over our LCD. Okay, our second fraction, or second rational, again, up top we have 2 binomials, so we're just going to leave it like that. And then we'll do more math on our next round when we actually start adding and subtracting with these rationals. All right, we're going to do a couple more just for factoring practice. There's no such thing as too much factoring. We got to get as fast as we can on it. So numerator, denominator versus numerator and denominator. That first numerator, negative 5x, cannot be factored further with it being a monomial. That denominator, though, does have a GCF of an x. When I factor that x out, I get x squared minus 1, and then that becomes a difference of squares. So I have 3 factors x plus 1, x minus 1 for my first rational. Our second rational, 2x plus 1, that cannot be factored further. GCF is 1, and it's an exponent of 1. But our denominator is trinomial, and so we are going to try a snowflake. First, let's look for our overall GCF. Our overall GCF is going to be a 1, so we can jump straight into that snowflake. We're going to do A times C, B on the bottom, our A with our X's. 2 numbers that multiply to negative 20 that add to a 1. So we need 2 numbers that are going to work for negative 20, and so that's going to be a positive 5 and a negative 4. And then, of course, we simplify our fractions. So 4x and 5 is prime, and so that's going to stay as a 4x plus 5. And then on that second side, 4x minus 4, we can divide them both by 4, and we would get 1x minus 1. So x minus 1 for our second factor there. All right, let's create our LCDs. So I see 1 factor in common. And so let's go ahead and start our switch method then. The first fraction has an x and an x plus 1 that we need to multiply in. And then now our second fraction has one thing extra that the first one does not have, and that's that 4x plus 5. And let's go ahead and multiply that in to the numerator as well. So our LCD, there are 4 of them, and then I'm going to write them in order from monomial to binomials, and then trinomials, of course, would be at the end. Always go shortest to longest. And then our equivalent expressions. And again, it's just taking that time to rewrite it, which right now seems a little silly, but it will make more sense in the next part. And then we've got 3 factors. And so again, I'm just putting the monomial in front and the binomials in the back. All right, last one, factor all the parts. So we've got, sorry about that, we've got an x cubed, and it's on its own as a monomial, so that's going to stay. X cubed plus 8, that is going to be a sum of cubes. We do have a GCF of 1, so I can cube root, get my A and my B, and then plug it in to our A plus B, and then our A squared minus AB plus B squared. Okay, on our second fraction, our numerator x minus 7, that is linear with no GCF other than a 1. And then on bottom, we also have the linear, and that one does have a GCF of negative 7. And then when I divide by that, I get x plus 2. So again, for that LCD, you can see that there's something in common already. So those x plus 2's will not switch since they're already there. But my first rational has a trinomial that was missing from the second rational. And then our second rational has a negative 7 that is missing from there. So we have 3 factors in order from monomial to binomial to the trinomial. And then our equivalent expressions, we can multiply these two together. And so we would get a negative 7x cubed, just to be a little bit easier to work with, again, over our LCD. And then our second rational, that's a binomial with a trinomial. Let's go ahead and leave that in factored form. All right, so just to refresh what those steps are, because it looks like a lot of writing when you look back at this. Remember this section here, where to create the common denominator, you're going to factor and then identify your missing factors so that you can trade them to the missing pieces in that switch method. And then just make sure that you keep your balance to the numerator and the denominator.